Hey everyone, and welcome. If you're an SPM student getting ready for your chemistry exam, you are in the right place. In this quick explainer, we're going to break down everything you need to know to really master the topic of glass and ceramics. Let's get started.
So let's kick things off with a little puzzle. Think about your phone screen and a coffee mug. I mean, they seem totally different, don't they? One is see-through and sleek, the other is solid. You can't see through it. But believe it or not, they share a secret ingredient that is absolutely crucial for your SPM syllabus. Any ideas what it might be?
And the answer is silica, or, as you'll see it in your exam, silicon dioxide. And you absolutely have to remember this formula, SiO2. This simple but really powerful compound is the fundamental building block for both of these amazing materials. It's the starting point for everything we're about to discuss. Okay, so here's our game plan for this explainer. We're going to start with what they have in common. That's the silica connection. Then we'll open up the glass recipe book to see how different types are made. After that, we'll look at how ceramics go from clay to champion. Then the big one, the showdown between glass and ceramics. And we'll wrap it all up with your SPM exam takeaway. Ready? Right, first up, the silica connection. So what exactly makes these two materials part of the same chemical family? Well, it all comes down to that shared ingredient, silica. We're going to look at the core properties they both share because of it. So this here is your baseline. These are the properties for both materials. Think about it. They're hard, but they're brittle. You can't scratch them easily, but if you drop them, they shatter. They're also chemically inert, which is why we can use them to hold strong chemicals in a lab. And of course, they're great insulators. So keep these shared traits in mind as we start to pull them apart and look at what makes them different. Okay, let's move on to our glass recipe book. I want you to think of pure silica as your basic flour. Now, by adding different chemicals, it's kind of like changing a recipe to bake a completely different cake. Each new ingredient we add gives the final glass a totally unique and special property. First up, we've got fused glass. Now look at its composition. It's almost 99% pure silica. And because of that, its superpower is an incredibly high softening point. We're talking 1700 degrees Celsius. Wow! This extreme heat resistance makes it perfect for all the high-tech stuff. You know, like telescope lenses and the optical fibers that bring you the internet. Now, let's talk about the glass you see pretty much every single day, soda-lime glass. When we add sodium oxide and calcium oxide into the silica mix, that softening point plummets all the way down to 700 degrees. This makes it really cheap and super easy to mold into all those common items, like bottles, jars, and window paints. Okay, pay close attention to this one, because this is a classic exam favorite. The magic ingredient in borosilicate glass is boron oxide, B2O3. You gotta remember that. This compound changes the structure so it can resist sudden changes in temperature. And that's exactly why your lab beakers and your glass cooking dishes don't shatter when you take them from hot to cold. And finally, lead glass. This is where chemistry really creates beauty. By adding lead oxide, PbO, the glass becomes much, much denser. This gives it a high refractive index, which is really just a fancy way of saying it's amazing at bending light. And this light-bending superpower is what creates that brilliant sparkle you see in fancy crystal glasses and prisms. All right, let's switch gears. We're moving from glass to ceramics. Now, if glass is all about mixing precise chemical recipes, ceramics are all about transformation. We start with just humble clay from the earth and, using some intense heat, we transform it into something incredibly strong and durable. The process here is pretty simple but really powerful. Step 1, you start with clay. Now for your exam, remember the key component here is aluminosilicate. Step 2, you shape it into whatever you want. And step 3, you bake it in a special oven called a kiln at very, very high temperatures. It's this intense heat that permanently changes its structure and makes it super hard. And this just shows how versatile ceramics are. You can directly connect the property to the use. Because they're hard and strong, well, we use them for bricks and tiles in construction. Because they're great electrical insulators, they're essential for things like spark plugs. They're so inert and hard, they're even used for things like artificial teeth and even as semiconductors in computer chips. All right, it's time for the main event, the showdown. Glass versus ceramic. This is the ultimate comparison, and trust me, it's a classic exam question. So let's put them side by side and lock in the key differences you absolutely positively must know. Okay, this slide is your golden ticket, your ultimate cheat sheet for telling them apart. Let's break it down.
Glass is transparent, right? You can see through it. Ceramic is opaque. You can't. When you heat glass, it just gets softer and softer. But a ceramic has a very high, very distinct melting point. And lastly, glass is impermeable. Water can't get through it. Ceramics, on the other hand, are usually porous, meaning they can soak up water, unless, of course, they've got a glaze on them.
We're in the final stretch now. I know we've covered a lot, so let's boil it all down to the absolute must-know facts, the key takeaways for your SPM exam. Look, if you remember only one thing from this whole session, make it this. For your exam, you have to connect the chemical composition to the property, and then connect that property to its use. For instance, why is borosilicate glass used in labs? Well, because adding boron oxide, that's the composition, makes it heat resistant, that's the property, which is perfect for lab work, that's the use. If you can make those connections, you are going to score top marks. And to finish off, here's a little challenge for you. You now know the basic rules. You know the building blocks. So, what's next? If you could mix and match these components, what kind of incredible new material could you invent for the future? Have a think about it. All the very best with your studies.